Okay, hello everyone and welcome to the latest TU-Automotive webinar. My name is Jamie. I'm a project director over here at TU-Automotive. It's the afternoon in London, so we're going to do our best to get through this so that I can have some time to nip to the pub on a Thursday afternoon. But it gives me great pleasure to welcome our panelists today, who are Tim Dawkins, Autonomous Car Specialist at SPD, and Brett Hillhouse, who is a Watson IT Connected Vehicle Platform and Automotive Solutions Executive at IBM. Gentlemen, it's great to have you here. The topic for today's webinar is AI, the brain behind the autonomous vehicle. As most of us have no doubt seen in the press, a lot of attention around AI, but we're going to get beyond the hype with our two panelists today and try and uncover some of the nitty-gritty of what AI really means to the autonomous vehicle. But that's quite enough from me. So I'd like to hand it over to our first panelist for today, Tim Dawkins. Tim, if you can get your screen ready for screen share, I'm looking forward to hearing some of your insights. Just a quick reminder to our audience as well, at the end of this webinar, we will be taking questions. So if you can submit your questions via the question tab that you should have through the webinar system, I'll be able to ask those to our panelists at the end. But for now, Tim, I'll leave it to you.
All right, thank you very much, Jamie. Good afternoon. And just to double check, you can all see my screen okay. So thank you again for inviting me to speak at this webinar today. It's a real honor to present to you guys on the subject of AI for autonomous vehicles. So to start things off, I'm going to provide something of a primer on the applications of AI for autonomous driving and what it really means for the industry, where we're trying to get to. So, in terms of our material today, I'll start off with a quick introduction for those who are perhaps a little less familiar with SPD, who we are and what we do. And then we'll take a quick look at some of the current applications of AI for autonomous vehicles to see how the building blocks are being used in various elements of the software stack and touch on the challenges of its implementation. And finally, we'll wrap things up with an overview of the emerging landscape, who the key players are emerging in AI and what their key areas of interest are in AI for automotive. So, quick intro to SPD. We're an automotive technology research and consulting firm. We've been in business for over 20 years and have 6 locations globally, working with the majority of OEMs and Tier 1 suppliers wherever we're needed. We support our clients with both off-the-shelf research and vehicle data, as well as bespoke support in everything from user experience testing and benchmarking to M&A due diligence and strategic planning. We're headquartered in Milton Keynes in the UK, and I join you today from our office in Ann Arbor, Michigan, where I head up our autonomous car research in North America. We have 3 core areas of expertise: connected car technologies, including infotainment, navigation, apps, remote services, and telematics. Our autonomous car practice, which I represent, includes everything to do with current ADAS systems, sensors, sensor fusion, and driver monitoring systems. And finally, vehicle security, very much the genesis of our organization. Our practice here includes both anti-theft technology as well as cybersecurity evaluations. So, introductions aside, let's get into it. Let's start exploring how AI can be applied to the autonomous car. Let's start not with a direct application, but perhaps a useful metaphor to set a tangible benchmark for the degree of intelligence we're shooting for. For this, we shall introduce the idea of a horse. A horse has a basic sense of self-preservation. It won't walk off a cliff or run into a wall that it comes across, at least. This, of course, is a desirable characteristic. Secondarily, a horse has, at least on a very basic level, the ability to follow a trail or path with minimal inputs from the rider. And finally, again, on a basic level, a horse can respond to simple commands, even emotive ones, in a very basic way. And think about the way that you might interact with a horse when you're riding it. It's through suggestive inputs, not by grabbing its legs or pulling its tail, but with suggestions and nudges, making it something of a steer-by-wire application. Before I get too far down that rabbit hole, let's refocus. There are certainly aspects in which AI in the car can and will, of course, be superior to the intelligence of the horse that we've described here. Equally, the AI will be superior to the intelligence of the human brain even. And naturally, there are areas where this metaphor may fall apart. For example, if you leave a horse unattended, it'll plot a path to the nearest patch of grass and start eating it. But nevertheless, the horse metaphor is useful because there's a common understanding among us, at least for this purpose, of how a horse will behave in certain situations and what it's generally capable of. It's certainly a useful benchmark for the degree of intelligence that we're shooting for, if you directly substitute an autonomous car into these scenarios. So with this as our benchmark for purposes of this exercise, how do we build this with AI? The 4 building blocks we need to do this can be divided into 4 domains. Perception, enabling autonomy, and then on the other side, interaction, enabling personality. When all levels are reached, the ultimate level of intelligence of perhaps our horse can be achieved. Let's go through these one by one. Perception, of course, refers to the understanding of the vehicle and its environment, also to an extent its occupants, through the analysis of raw sensor data to detect and classify objects, as well as estimate the area in which the vehicle can drive. The overall outcome is what we call an environment model. Now, building on this, we have a degree of autonomy. In this context, we're referring to the ability to navigate through the environment model with trajectory prediction and path planning, and ultimately the dynamic control and behavior of the vehicle. On the interaction side of the scale, we of course mean the exchange of information with the driver. This refers to, of course, the ability to recognize his speech, his gestures, and to an extent his emotions to create a multimodal user interface. And then building on this, we can create an element of personality, the ability to understand his state and his intentions from his commands, such that a natural communication is established between the driver and the vehicle. All these come together to give us a degree of intelligence which may be considered akin to the horse that we described earlier. Let's take a little deeper look into how this is being developed today. So, these functions are some of the most important elements of an autonomous car's software stack, and of course are suitable for some of the key recognition and analysis tools enabled by AI-based algorithms. We can group them into interior and exterior domains, or perhaps driving functions and occupant functions. And in each of these buckets, if you will, we can dig a little deeper and break them out into a number of specific use cases that are suitable for AI-based solutions. But it's not all roses. While the development of AI has been accelerating rapidly in the last few years, there are still a few challenges before it can be truly put into the mainstream, at least for the safety-critical applications that we're considering to do with the control of the car. Like any piece of software, AI algorithms must be validated, and if they're generated by self-learning techniques, how do you validate the incremental changes? How do you track them, especially with a full and complex stack? Building on this same theme, how do we demonstrate robustness against either current expectations for functional safety, or how do we adapt such standards to accommodate for artificial intelligence? Now, given that this idea that AI will be controlling the vehicle, we currently certify our human drivers. Will we be required to certify our algorithms to the same standard? Now, on a more practical level, lots of the applications that are developed, certainly with deep neural networks, require a large amount of training data for algorithm development. And this is great for applications where we have lots of data, video data, audio data, everything from speech recognition to sign recognition. However, how do we expand this to cover corner cases? The corner case of perhaps a mattress falling off of a vehicle. Sticking with these practical terms, hardware optimization is a very real concern as well for AI-based applications. One current example, NVIDIA drives PX2 boards that are used in many neural network-based applications for development vehicles consumes up to 250 watts of power. And it's safe to say by automotive electronic standards, that's a lot. And finally, looping back around to safety constraints, cybersecurity, always a problem with software in autonomous vehicles, and doubly so for AI. How do you demonstrate that you've put in intrusion detection, tampering safeguards on self-learning vehicles? Equally, an AI-based car presents new ways of being interfered with. Multiple researchers have also shown that tampering with road signs can fool machine vision systems into misclassifying technologies. Road signs, sorry. So that's a little primer on the applications and the challenges. Now we're going to take a look into who the various stakeholders are in developing AI for autonomous driving and what their underlying interest may be in this section of the industry. So AI is seen as one of the key building blocks to deliver as autonomous vehicles by many, and lots of companies across the industry are actively seeking to expand their software portfolio to support either computer vision or other machine learning-based applications, either via acquisitions or partnerships. We've seen a huge amount of activity from everyone from the OEM side to suppliers and the tech companies trying to buy up startups left, right, and center. Naturally, a huge amount of these innovations are coming from the big tech companies. And a lot of them are targeting developing the end-to-end autonomous driving stack on their own, especially in the case of people like Uber and Baidu. And secondarily, a lot of these tech companies are also extending their personal assistant products into the car. Now, of course, naturally, academic institutions are also a big driving force in this area of development. And some of the more up-and-coming startups in autonomy have actually spun out of robotics labs from universities. Among the semiconductor suppliers, there's obviously a great deal of momentum toward developing the supporting hardware that's required to deliver these systems, but also building SDKs, so software development kits, and operating systems to run AI-based algorithms through for their development partners. On the Tier 1 side, it's no secret that in automotive, they're all transitioning to becoming software suppliers. And that's doubly true for AI-based applications. They're seeking to secure their position as an end-to-end system integrator, and as well as that, providing dedicated sensor fusion domain controllers integrating the latest and greatest chipsets from their Tier 2 partners. Of course, there's an ever-increasing number of software startups who are targeting development of AI to support autonomous vehicles as well. And it's difficult to generalize their applications. There are those out there that are developing one little element of the stack, and there are those that are trying to deliver the entire vehicle. But of course, a very interesting area, and where, of course, we're seeing a lot of targeted M&A activity. And then finally, on the OEM side, not wanting to be shut out of the feature development, many OEMs have doubled down on their R&D efforts in AI recently so that they can control the end integration. And as we've said, that includes obviously some very aggressive acquisitions or partnerships to help deliver these features to market. So a quick summary before I hand things over to Brett. So today we just reviewed a base level of the applications that are being targeted by the industry for autonomous vehicles and the applications of AI to suit them, and took a look at some of the key building blocks to achieve a given level of intelligence. We also took a look at some of the barriers to deployment at a very high level and a quick sweep of the emerging landscape so that we can see how things are shaping up. So I hope that was a useful little primer, and I thank you all for attending today and giving me your attention whilst I shared some insights. I'm going to kick things back over to Jamie and Brett for the rest of the session.
Okay, Tim, thank you very much. I'm sure we agree that was a great intro to this topic. Just a quick reminder to all of you listening that the recording for this session will be sent out. I'll be sending that out tomorrow morning. So for you guys in the US, just look at your inbox in the morning and you should have the full recording there. So if you do miss anything, you have the opportunity to look at that. But we will hand over to our next presenter today. Our next presenter being Brett Hillhouse from IBM. So we will just transfer the screen over to Brett now, and we will get started with his presentation. Just a reminder that after Brett's presentation, I will be putting your questions to our presenters today, so please keep those questions coming in. Okay.
And certainly logistics-wise, there's nothing worse than if you get on stage and it's not fully prepared. It has the reverse effect.
Hi, Jamie, just want to make sure screen's good and everything.
The screen is good and we can hear you loud and clear, Brett.
Great. So thanks for the start off, Tim. I'm going to take just a slightly different approach here on what we're doing around AI and what we're seeing companies do in applying it even from not just within the vehicle, but from the cloud. And really what we can say is that there's been a tremendous amount of work already done on artificial intelligence in the cloud today. It's where we would argue, probably the bulk of that intelligence is available out there today. And as Tim mentioned, there are associated costs with putting AI in the vehicle. So there's a lot of discussion and a lot of work going on how do we find the right balance of putting intelligence in the vehicle and then perhaps augmenting that by having it in the cloud. In IBM's case, we often talk about what we're doing around Watson as an augmented intelligence. It's not meant to be a self-aware, pass a Turing test kind of intelligence. We're really looking at our AI as being very focused on helping the system, the driver, to be able to do their own tasks and their things, and really being able to improve their ability and their day-to-day work that they're doing. So just understanding how we're doing this, we do see, clearly there is edge technology for AI that is already moving into phones, it's moving into your cars and commercial vehicles. But there's a tremendous amount that can also be done in the cloud. And I'll try and walk you through some examples of that, and then also walk you through what we believe are some of the key steps and imperatives that we should be following as we're doing this type of artificial intelligence in an autonomous vehicle, or even just in a connected vehicle, because this applies across any connected vehicle, obviously, on being able to have the cloud and the vehicle working together. An example of that is one that we've done with Local Motors on Ollie. If you're not familiar with Ollie, you can do a Google search on Watson and Ollie. And what we announced last year, around this time, actually, just a little over a year ago, was the first autonomous and cognitive shuttle bus that we've created in conjunction with them. And we really leveraged the Watson capabilities for natural language in Ollie, and we thought that that was a very important one. How do you make a consumer, how do you make that passenger comfortable that we're in an autonomous vehicle? How are they going to be able to interact? So I think Tim made this point as well. You need to have a natural way for them to be able to ask a question. Why did we stop here? Ollie, why did we swerve? So you want to be able to think about it in that fashion. How are you going to interact with them when they're not the one controlling the vehicle anymore? The second piece was we're seeing the cloud also was very helpful in doing the training. Right? We talked about all the extra data you need for these neural networks and everything, as Tim put. That's very well put. We see the cloud as being an extremely important place to do the training. What we did with Ollie is we even opened up this to crowdsourcing the training on Ollie. So we opened up within IBM to allow all of our folks within our IoT organization and our services organization associated with this to be able to do their own training. So we suddenly had thousands of individuals out there helping train Ollie become smarter. So they were asking the type of questions that you would want to be able to ask if you're an autonomous vehicle. We learned a lot during this process. And in fact, we learned some things that probably were not the most positive as well, which is sometimes people don't actually treat these autonomous vehicles very kindly. So some of the interaction was actually found a significant subset of the folks who don't necessarily treat them with the respect you might expect. But besides that, this is not the only example that we see of using this to create the AI learning very well. A good example that we're doing with Tier 1s right now is specific to training the autonomous systems. So rather than putting a tremendous amount of additional compute power in their vehicles out in the field, where they're training their autonomous systems and improving their autonomous systems, leveraging the cloud such that you're doing it with the intelligence in the cloud to help with that training and to help change those algorithms. So the whole idea of driver behavior that Tim mentioned, how can I make the driver behavior of that autonomous system more comfortable for a human being or more predictable? So being able to tweak those algorithms and have 100 vehicles out there at the cost of what would have been just a few fully wired up and trained ones in an offline mode. And that's also being used in vehicles in the market today. So we see that today with Tesla, right? They have been able to put out a product that has some great ADAS capability and be able to improve it over time. And they're leveraging the learnings of those vehicles out in the field. So and it's something that we're kind of surprised we haven't seen more of this from the OEMs, in that we've had connected vehicles for quite a long time, but we weren't necessarily had them connected with the idea of being able to do continuous improvement. Just understanding how users are using the system, how they're responding to it, as well as how well the system is performing. So let me go on just a little bit more and talk and give you some examples that we're seeing, that we think these are some of the imperatives that we need to be thinking about in achieving these autonomous vehicles and putting AI into those autonomous or even just a connected vehicle. So one is obviously the cognitive piece. Tim and I have both talked about that, but it's understanding, reasoning, learning. Clearly having a natural way of conversing with the system. The second one is the context that you're in. Understanding and being able to react in real time to situations, but being able to change that, what that reaction is. Be able to change the action you take based upon the context that you're in, due to weather, due to traffic, due to perhaps the person being tired or distracted if it's actually in a passenger vehicle with somebody who's driving, or I'm only an autonomous 4 level, and I'm in an edge case where we're going to have to transfer, possibly have to transfer it back to the human driver. So we want to understand the context, and you may have very different actions that you take. So Tim talked about as well the driver behavior. So let's say we understand from driver behavior, and you can do it from a camera facing them, where you might see somebody's distracted, blinking rates change, they're tired, or it's steering inputs, a number of different ways to understand that driver's behavior has changed a little bit. And he's tired, he's distracted. So what do you want to do with that person? Well, what's the context, first of all? Do we know where that person is going and how far they still have to go? If they're only a mile from home, you might just jiggle the seat or put an alert out. But if the person has 50 miles to go, and maybe it's 3 o'clock in the afternoon, you might offer them, hey, why don't you take the next right off the interstate, and we can, order, we've already pre-ordered your favorite latte. It's, at the drive-through window at Starbucks. So you can take an ADAS situation and solve it with a problem like that. Similarly, you can do the same thing. What if it was at night, and they have 200 miles to go? If it's a commercial truck driver, you might suggest the next truck stop or rest area, or you might offer a coupon for a hotel if it's a passenger. So in a connected vehicle where we still need to, until you get to full autonomy, we're going to have to still be paying attention to those types of situations. And then the other piece is really focused on understanding the customer, understanding the occupants. So personalized, it needs to learn about you and what you like to do, where you're going, what are the types of things that you enjoy on a road trip that you might want to hear about, that your kids might want to hear about in the rear entertainment sites. So I know you have that 200-mile journey. Perhaps there is a set of points of interest around, maybe it's Revolutionary War sites or something, and your kids are interested in that. That's something that's learned about you, and it can help, perhaps tell the kids about that in the rear seat. Keep hopefully trying to reduce some of that, hey, Dad, are we there yet, kinds of things, right? And we want it to be proactive. We want to not just be able to say, hey, as a personal assistant, open the garage door and turn the lights on. We want it to automatically be doing those things. As you're driving home, you're getting close to your driveway, it's going to open the garage door. And if it's dark out, it's going to turn the lights on outside. Even if you're an autonomous car, the human's going to be more comfortable if they've got the outside lights on, right? So it is thinking about it in those ways, as well as being portable. So think about the personal assistant needing to be able to go from the home, where you might be talking on a smart device to it, to saying and reminding them, hey, you've got your trip ahead of you, it's going to take you 35 minutes, your Google can do that on your phone today. But is it doing it in the context of, hey, you're also low on fuel, you're going to need to stop for gas on the way? Or your EV range is right at the limit on it, we're going to want to make sure you do a way stop at a charging station. So starting from the home, setting up the vehicle, getting it ready for your personal preferences, you're getting in the vehicle, you want to be able to carry on perhaps that same conversation and have the same type of experience that you can have with your personal assistant in a home setting, on a phone, in a hotel room, or in the car. And the way that we see this really coming about is by spinning up digital twins of the vehicle, the environment, and the context that we're in. So that context for the vehicle and the driver in a real-time fashion, allowing you to make actions and take an action such as that ADAS situation where you decide based upon the context what's the type of thing you're going to do for that driver or for that person. And we do think that this is going to continue to be this kind of idea of a hybrid embedded solution on the edge in the vehicle and augmented in the cloud, because it's just the pure cost alone, capabilities, as well as perhaps that idea of being able to understand the context around them is still some of those edge case or corner cases that you talked about, like a mattress falling off a vehicle. It's an obstruction in the road. How do I deal with that? That's something that just happened. It's not necessarily something that you're going to be able to see. So do I want to tell it to the cloud, update my map such that we start to route all those AI cars around it? And then even things like security we talked about briefly with Tim. I'll give another example. At TU Update in Detroit, we actually came out with a number of tier 1s about being able to look for anomalous behavior in the ECU network on the vehicle. Now, that could be good. It could be because there's a new update that we just did over the air, or it could be bad, that there's actually, in the context of a geo-fenced area going down the interstate, there are additional vehicles popping up with that same anomalous behavior on them. That might be an active attack. So we're thinking through not only how do these AIs in the cloud help them, but it obviously must be augmented with real-time agents even on the vehicle, this idea of the hybrid capabilities. And the last thing I'll just say, we often see a lot of focus on AI and customer experience around offering coupons and other things. It's not just about commerce, and it's not just about making additional money from this connected vehicle information. It's also, we see some of the OEMs very focused on brand differentiation through really focusing on the customer experience. You're going to want them to be in that autonomous vehicle. You're going to want them to be in your vehicle because that experience they get is the best across any of them. They're not going to want to give up that brand for another one because it's not going to be as much about how the car feels and how it drives, right? So thinking about how the experience can be increased. Big part of the focus we're seeing from our clients today. Jim, Jamie, I can turn it back to you.
Fantastic. Thank you very much, Brett. So we will move on now to a couple of questions. So if any of you do have any questions, please submit them. I'm going to start asking a few questions that we've got now. So one of the first questions that we have here is, how do you ensure cybersecurity within an AI engine? Brett, I think I'm going to stick with you on this one for now. So again, the question is, how do you ensure the cybersecurity within an AI engine?
So I think one thing that we've learned from cybersecurity over the many years now we've been having computer systems and the internet is that, part of our point of view is just intrusion detection is not enough. Trying to keep it out. I think you have to believe that you are going to be hacked, you are going to have problems, and you need to be able to find that particular issue and take an action on it. And you can look at the driver behavior, for instance, in that scenario I was giving before. Let's take it to the next step. Not only did I notice anomalous behavior, I'm noticing anomalous behavior in a geofenced area moving down the interstate, but now I probably want to really pay attention to the driver behavior of that autonomous system or even the human driving systems. Are they changing? Are they changing in a necessarily way that we haven't seen before? That's probably a really bad sign. Do we want to get those affected vehicles over to the side and turned off as soon as possible? Do you want to turn on cameras around it so they can start to hopefully catch whatever that vehicle is that's doing the infecting? So you've got to think of it in a couple of ways. Obviously, intrusion detection is very important. All the capabilities at the chip level that are being added to vehicles are important, but at the same time, you can't think that you're going to just catch everything.
Okay, thank you, Brett. Tim, if you can hear me, any other comments on that question? Okay, I think we may have lost Tim for a bit there, so we'll get back to Tim in a bit. So Brett, I'll put the next question to you, and we'll see if we can get Tim back on the line. So Brett, the next question I've got is, if human drivers are not certified for emergency conditions, the mattress scenario, for example, why should the AI also need to be certified?
Interesting question. There's a lot of discussions on this at the regulatory level, obviously. I've been in some of those discussions myself with regulatory bodies asking about certification. There's a lot of different things that might be certified when it comes to autonomous vehicles. Today, there is not the same level of certification that you see for Food and Drug Administration, for instance, on medical devices, where essentially you are signing off to have hit all of the specific certifications from FDA perspective, including an app that interacts at all with on your phone, that interacts at all with that medical device, is considered part of the medical device and must have the exact same rigor, all of the process flows that are associated with it, all the digital thread, full understanding of how that product was created. And there is certainly discussion whether that's the right approach or a different approach that we've seen on the DoD side and around aerospace, which was more about process capability and being able to ensure they're following process. We all heard of ISO 9001, right? You have to be 9001 certified. There are automotive standards that are out there that are very well known that could be used in a process perspective. So there's a couple of different approaches to certification we're already seeing folks working on. I don't believe it is just specific to the AI system. It's more likely going to be about the vehicle and the connected vehicle, so it's a broader system than just the car itself. It's everything else that's associated with it from that connected vehicle perspective and the apps associated with it, etc.
Thank you, Brett. We've got Tim back. So Tim, if you've got a couple of comments on that question, I'd be delighted to hear them.
There's definitely a need to extend existing structured safety testing to cover autonomous driving. There's a pretty good consensus on that. And as we move towards AI-based control of the vehicle, we're definitely going to have to come up with at least a base level of functionality, a base qualification to assess the vehicles against, in the same way that somebody has to do a compulsory basic training before they're allowed out on the streets on a moped. So I feel perhaps there's definitely a need for a lot of dialogue in the development of that process with the industry, and there's a lot of leads that can be taken, as Brett said, from defense or aerospace or even drug administration as to how that can be put together to cover the consumer interests in the safest possible way.
Okay, thank you, Tim. Tim, I'll put the next question to you since you missed the last one. But the question we've got here is, will all of the data processing be done in a central computer in the car, or will there be a separate system running algorithms based on what data is being fed in?
That's a very good question. If we take the intent of perhaps a couple of examples who are already forging ahead with these technologies in the cars, we're definitely expecting there to be a dedicated board doing a very heavy degree of processing in the vehicles as they become more automated. We know from the examples of the Tesla Model S and the upcoming Audi A8 that that's going to be the strategy for the first partially automated features. Now, whether or not that will scale to the greater degree of processing that will be required with higher levels of automation and the massive amounts of data that comes with it is yet to be seen. We'll have to see if the boards and the chipsets will catch up appropriately. But as Brett touched on, cloud-based AI can provide a hybrid solution that enables some of the heavy lifting to be taken off the board. If we keep the safety critical aspects within the car and perhaps some of the more softer constraints acting within the cloud still, then that could perhaps provide the solution to some of the hardware constraints that we're coming up against.
Okay, thank you, Tim. Brett, I'm going to stick along a similar vein here and put the next question to you. So the question is, how large edge computing capabilities need to be on vehicles to provide real-time capabilities? So that question again is, how large will edge computing capabilities need to be on vehicles to provide real-time capabilities that we'd see in artificial intelligence systems?
I think there's a couple different elements to that. I mean, today the auto industry is very good at doing real-time systems. That's what we have today. That's what you have in any drive-by-wire, again, aerospace, etc. For the AI side, that is still being, I would say, worked on from an edge perspective. What is required? I think the Audi example and Tesla examples are very good that Tim just gave. I'd also state, though, that this idea of having an abstraction layer that is monitoring and helping make decisions for the AI is a different approach, and that's that spinning up of a digital twin. It's an abstraction of the vehicle, an abstraction of the autonomous system, and an abstraction of the context that the vehicle is in. And being able to look at that, that's fairly lightweight. We see companies beginning to do that today on vehicles, and in a real-time fashion. That's a very lightweight device, being able to run AGL or another operating system, and 150 megs of RAM. It's not huge. So there's different levels of this. I think the neural networks are still pretty heavy, as Tim, I believe, had already mentioned, but some of the other ones that can leverage AI technologies are not nearly as demanding.
Okay, Tim, sticking with the data theme we've got running here, the question I've got here, which I'm sure we've heard 100 times, but I think it's good to get your perspective on it, is how do you see the ownership of the data gathered by the vehicle? Will I, as a vehicle owner, also own the data the car is gathering and processing?
That's a fantastic question, and it's still, even with the relatively small amount of data that the connected cars are collecting today, it's still somewhat ambiguous, and it has to be constrained in an end-user license agreement. There's definitely going to be an opportunity to generate revenue from the data, but it'll be down to either the service provider or the OEM to secure ownership of the data in the first instance. So from the second that either the car is sold or the user signs up to their automated ride-sharing scheme, it needs to be very clear from the outset who has ownership of the data. Of course, this will vary by region, by country, according to privacy laws, but there's definitely revenue opportunities for everybody in the ecosystem. If you're the OEM, you can understand better about your users' habits, or if you're perhaps the rideshare system operator, if you have, again, habitual data, you may be able to provide more contextual suggestions to your customers. But of course, you've got to balance that against ultimately user privacy, as it always comes down to, and we may find that there's still a little bit of sorting out to do as to who owns what in the data ecosystem.
Okay, and kind of a follow-on from there, which I'm going to open up to both you gentlemen on the subject of data, is will vehicle data generated by autonomy be accessible to investigators when or if collisions occur for investigation purposes for law enforcement? It's different in Europe to the USA, perhaps, as we can see at the moment with crash data from ACM modules, but what's your take on this? This is a first come.
I suspect, if I may, that the evolution of, at least here in the US, the evolution of the federal automated vehicle standards will require essentially the level of EDR that we have here in the States today to be put on steroids so that they can understand the post-crash analysis, especially when it comes to questions of was it a vehicle fault that caused the collision. Brett, anything you'd perhaps like to add to that?
I totally agree, and I don't think any of the OEMs would argue with anything as long as it was a standard across all the OEMs and they're not having to try and make this decision themselves, right? No one wants to try and make this determination.
Okay, Brett, I'm going to stick with you for this for the next question, a bit of a technical one here, but how much onboard storage is going to be needed to support AI systems in the future?
Boy, I'm probably not the right one to ask that, because I don't believe we need, I think you only need the buffer from when you have those edge cases where you're not connected. I'd be arguing that the real question is how the heck are you going to deal with all this data that you're throwing up to the cloud at some point, because you can't store it on the vehicle. I don't know, Tim, if you have a different opinion on that one, but.
My only thing to add would be really how long is a piece of string. It depends vastly on the application and the level of feature that you're seeking to deliver, I guess.
Okay. We'll do two final questions now. So moving away from the data angle to an extent and looking a bit at autonomy. The question is, how likely do you think car manufacturers are in terms of going towards fully autonomous cars? And ultimately, do you think the infrastructure will be ready to reinforce this huge change we'll see when we see automation rolling out? So the question is, do you think infrastructure will essentially be ready for the rollout of the autonomous car powered by AI? Brett, I'm going to throw this one to you to kick off.
So I do believe that if we're really going to have fully autonomous vehicles, they're going to have to deal with no infrastructure. Agree that we will have areas in the country where we have very good V2I infrastructure that will allow autonomous vehicles to be on the road much sooner, but it is not, I don't believe anybody believes that you're going to have that in the future. The edge cases are still very difficult, where you're running into a situation where, you know, the drivers are very aggressive on a merging situation. So you're merging traffic from 5 lanes to 2. They're being very aggressive, not letting in an autonomous vehicle. If they don't have V2V capability where they're communicating to each other and you still have these human drivers in the middle of it, those are very difficult conditions, and no level of infrastructure is really helping with that interaction with the humans that are not being necessarily helpful to the other drivers.
Thank you, Brett. And one final question, I think, and then we will wrap this up. Gentlemen, I'll open up to both of you again. But essentially, when we're talking about the data and the artificial intelligence, one question that I've had come up a couple of times is, how do we keep connectivity with the cloud when there's limited data access in an area? So again, the question is, how will we maintain connections to the cloud when there's limited data access in a particular area?
Obviously, this is something that every one of the cellular providers and satellite providers want to try and fix. There are already pretty good cases where I can take and move from a cellular to a satellite system. So there are some folks that are out there doing that work, and there are certainly some applications for it. I think everything has to be designed for augmented by cloud technology, but as Tim said, must be able to do all the safety critical elements on there that could be enhanced. You might have additional options that you could take if it's connected, but clearly the autonomous vehicles are going to need to be able to run in a disconnected mode if needed. Whether a cell tower goes down, power goes out, whatever it might be, there's always going to be those cases where you cannot rely on the connectivity.
Just to echo what Brett's saying, I absolutely agree here, and really, yes, you're going to have to rely on an element of dead reckoning and the ability for the vehicle to operate at a basic functionality, even if they can't access the full suite of features. If it comes into a black spot or a dead zone where it can't receive the full level of connectivity it would like.
Fantastic. Thank you both very much. I think that's time on the Q&A. So that concludes this webinar. Just obviously mention that this webinar has been run in association with TU-Automotive ADAS and Autonomous Vehicles. The event takes place October the 2nd and 3rd. And you can find out more details on the event by visiting www.tu-auto.com/autonomous. All that remains for me to do is thank our panelists very much. Thank you, Tim. Thank you, Brett. I'm sure the audience would agree that your insights have been extremely fruitful today. So again, thank you very much for making the time to speak to us all today.
Our pleasure.
Thank you, Jamie.
No problem at all. Very glad to have you guys on board. But that's it from TU Automotive headquarters. It is nearly 6 o'clock here, so it's about time I headed off to the pub. Wish you all a very good weekend when it comes around. But apart from that, if you have any questions, get in touch, and the recording for this webinar will be sent out tomorrow. But that's it from here. Thank you very much for listening, everyone.